All right, guys, so we are moving on to 4.4F factoring quadratics with an A that is greater than 1. So, again, just to look at standard form again, we have ax squared plus bx plus c. So what we're talking about is an A term right here that would be greater than 1, okay? And it creates a totally different strategy that we have to look at with these particular types of problems. And again, this is going to kind of go back to that grouping strategy that we used a couple of sections ago. So again, you're going to understand now why we did that and why we actually looked at that. So I'm going to look at two problems. I'm going to go ahead and warn you, these are the most time consuming and maybe the most confusing. I'm not sure. But again, hopefully once we go through this, you'll be able to do this with ease and won't have any issues. So let's look at an example problem here. We'll call this problem number 1. And we've got 5x squared plus 17x plus 6. So you notice, again, and this is something you should probably get in the habit of doing, is always try to see if you've got any common factors. You notice my coefficients here are 5, 17, and 6. So 5 doesn't go into 17 or 6. 6 doesn't go that way either. So there's really no common factors here. Also, you notice there's an x squared here, an x there, but no x there, right? So we don't really have any common factors we could pull out. So that's not really an option. I know that one of the last problems that we looked at last time, you could pull out a 2, but in this instance, we don't really have anything that we could pull out, okay? So now I've got to use a different strategy. Usually, if this was a 1, for example, then I always just looked at this C term, but I cannot use that strategy with this particular type problem. So here's what you have to do, okay? This is where it gets tricky. When you have an A term that is greater than 1, okay, A is greater than 1, which means, again, it's a stretch if we're thinking about it graphically. But if you have an A term that is greater than 1, then you need to take your A term and multiply it times your C term, okay? So A times C, and then that is the number that you're going to factor, okay? I know that sounds like really confusing, but if this is greater than 1, then you have to take your A term and your C term and multiply them together, and then that's what you're going to factor. So in this case, you've got A times C, 5 times 6 equals 30. So 30 is the magic number, okay, that we're going to really be shooting for. So let's think about the factors of 30. This part of it is exactly the same. It's 1 and 30, 2 and 15, and 3 and 10. Let's see what else. We have 5 and 6. All of those are terms of 30, right? Now, notice I have addition here, so that comes into play as well. That tells me I'm going to add, and this part of it is exactly the same as well. I'm trying to add two of these numbers together to come up with this positive 17x, this B term, okay? So that part of it is exactly the same. The only difference is instead of just taking C as our factor, we actually have to multiply A times C in order to figure out what needs to be factored, okay? So let's think about this. What numbers over here could be added together to make 17? 1 and 30 is definitely not it. That's 31. 2 and 15, however, do add up to be 17. So these are my factors that I'm going to use. Now, here's the other part that's a little bit different, okay? What you're going to do right now is you're just going to rewrite this middle term using these two factors. And here's what I mean. So the first thing we're going to do is just bring down the 5x squared just like it is. I'm also going to go ahead and bring down the positive 6. Now, you notice I left some room in here, okay? So these two terms come down exactly like they are. Nothing really changes there. All I'm really going to do is rewrite this middle term as these two terms, okay? Now, here's my question to you. Does the 2 seem like it goes with the 5, or does the 15 seems like it goes with the 5? Because you're already trying to think about trying to group these things, okay? So in my mind, a 2 will not go into a 5, but a 5 will go into a 15. So that means I need to get this 15 close to that, okay? So watch what happens. I'm going to take this 15 right here, and I'm just going to put it here, positive 15x. All I'm doing is I'm I'm rewriting this term as these two terms, okay? Which means that if I've got 15x, then I need to add 2x to it. Now, I want you to think about this just for a second. Just pause for a second and think about the fact that we have not changed our problem at all. The problem is if I add these two terms back together, I'm going to end up with 17x, right? I want to end up with the same thing. I've not really changed my problem at all. All I've did is I've kind of broke it into some terms maybe that I could use a grouping strategy to help me solve. Now watch what happens. This is where the magic really begins to start because I still don't have common terms in all four terms, but I do have common terms here. So again, you see how that grouping strategy is coming into play to help us to factor these particular types of quadratics. So then it goes right back to what we've already learned. I'm looking at this first binomial and I'm looking for what it has in common. What is its greatest common factor? Well, 5 will go into 5 and 15. I also have an x that these two terms share in common. So I can go ahead and pull out an x. That now, again, I'm just focused here. I'm not even focused over here yet. 5x times what will give me 5x squared? Well, I need one more x, right? 5x times what will give me 15x? Well, 5 times 3 makes 15x. Now, remember, from our grouping strategy, what did we do? Whatever term we have here, we're going to repeat it right over here. And now I'm looking at this set of terms and I'm saying, okay, what times x will make 2x? Well, I need to multiply times a positive 2. And positive 2 times x will make 2x. Positive 2 times 3 will make positive 6. And now again, it is right back to that grouping strategy. Last but certainly not least, I'm going to go ahead and write my x plus 3 first because this is the one they have in common. These other two terms become my other binomial. And again, if we multiply all this back out, we might as well go and do it. We only got two problems. I'm going to move this over here. X plus 3 times 5x plus 2. If I do full, x times 5x is 5x squared. X times 2 is 2x. 3 times 5x is 15x. 3 times 2 is positive 6. The only like terms I have are in the middle. So I have 5x squared plus 17x plus 6, which was my original problem that I started with up here at the top. Okay, so again, a little bit more involved, but I want you to see that it's using some of those same things that we've been using all along. So this right here would be our answer. Okay, all right, let's go ahead and erase out a lot of this. And again, if you say, oh no, we just lost all that work that we just done, we'll just pause the video and go back. And let's look at number 2. So for number 2, we have 9x squared minus 20x plus 4. Again, no common terms that I could pull out. There's not an x in every term. 4 definitely will not go into 9. So again, what do I do? If I have a term that is greater than 1, then I need to take a times c. Okay, so again, I'm going to take my a term here and my c term here, and I'm going to multiply them together, and that's going to be what I try to factor. So 9 times 4 is 36. 1 and 36 is a factor. 2 and 18. 3 and 12. Again, this is where those multiplication facts kind of come in. 36 divided by 3 is what? And you can use your calculator to do that too. It doesn't matter. 4 times 9 and 6 times 6. And now as soon as I got the same number, I know that I've did all the factors. Boy, 36 got a lot of factors, don't it? But again, I'm always looking at this symbol to know what to do. So I need to add two of these numbers up together that are going to come up with a negative 20x. So what two numbers over here will add up to negative 20? Well, these two numbers, 2 and 18, will add up to 20, but in order to make a negative 20x, remember back from yesterday, I'm going to have to make both of these negative in order to make that negative 20x, okay? So again, when I've got this situation where a is greater than 1, I'm just going to bring down my 9x squared. I'm going to bring down my positive 4, and I'm really just going to rewrite this middle term is all that I'm worried about rewriting. So I'm going to take my negative 2 and my negative 18, and I'm going to put them over here. Now, again, I'm going to ask the same question that you should ask yourself. Does the negative 2 go with the 9, or does the negative 18 seem to go with the 9? Well, we know that 9 goes into 18, so that's probably the one we should group with it. So negative 18x minus 2x. Again, if I add this back up, it's still going to come up to that. I've not changed my problem at all. I've just simply grouped it and broke it apart so that I can use a grouping strategy. All right, so here we go. There are my two groups that I'm going to start with, and I'm going to start with this first one. Again, I can pull out a 9. I could also pull out an x, right? Because both of them have an x in the term. So 9x times x will give me 9x squared. 9x times negative 2 will give me negative 18x. So again, as soon as I have this, I know it needs to be repeated. And then what times x will make negative 2x? Remember, this negative is with that. So that needs to be a negative 2. Let's make sure it worked out. Negative 2 times x is negative 2x. Negative 2 times negative 2 is, in fact, a positive 4. So everything worked out. Last but not least, x minus 2 is one of my binomial terms. And these two things right here that are left over end up going in the second one. Okay? So using some of your previous knowledge, you said, I didn't think I'd ever use that again. Well, guess what? We're using it right now. So hopefully this has been helpful. Again, your problems look exactly like this. So you're not going to shouldn't have any problem with this. If you do, obviously, reach out to me or Miss Wheeler, and we would be glad to try to help you along with this. Okay? Thanks.